Hello everyone, I'm Varsha Tandur from Sri Venkateshwara College of Engineering. I'm back with another topic, vector space and linear transformation. In this video, we will study in brief about the vector space and linear transformation and also their applications. Coming to the subtopics, which are the building blocks for the vector space. They are vectors and matrices. Vectors are mathematical objects that can be added together and multiplied by numbers to create new vectors. They have numerous applications in computer graphics, scientific simulations, and cryptography. Matrices are rectangular arrays of numbers that can be used to represent geometric transformations, solve systems of linear equations, and perform operations on vectors. Linear transformations. Linear transformations are functions that preserve vector addition and scalar multiplication. They play a central role in many areas of mathematics and science. For the examples, they include rotations, scaling, shearing, reflection, and projections. These transformations have important applications in image processing, computer vision, and robotics. The importance of linear transformations. It is a fundamental concept in mathematics and science because it allows us to simplify the complex systems and solve problems more efficiently. What are eigenvectors and eigenvalues? Eigenvectors are special vectors that are only scaled and not rotated by linear transformations. Eigenvalues are the corresponding scaling factors. Uh, for the applications, eigenvectors and eigenvalues have many important applications in computer science and engineering, including image compressions, data analysis, and machine learning. Properties of eigenvectors and eigenvalues. They have numerous interesting properties, such as being perpendicular to their associated eigenvectors and forming a basis for the vector space. Now we will look into the factors of vector space, which are the basis, dimensions, and the linear independence. Basis for a vector space is a set of vectors that can be used to represent any other vector in that space. The choice of basis can have a profound effect on the representation, visualization, and analysis of data. The dimensions. The dimension of a vector space is the number of vectors in a basis for that space. Studying the dimensionality of a problem can help reduce its complexity and uncover hidden patterns. Span and linear independence. The span of a set of vectors is the set of all possible linear combinations of those vectors. Linear independence is a key concept that determines whether a set of vectors spans its entire vector space. Now for the applications, how the concept of vector space and linear transformation are made use in real life. Vector space and linear transformation find its applications in three areas: in computer programming, robotics engineering, and scientific simulation. In computer programming, the vector spaces and linear transformation can be used to represent and manipulate data structures such as matrices, graphs, and tensors, and to develop algorithms for operations such as image recognition, compression, and filtering. In robotics engineering, it can be used to model the position, velocity, and orientation of robots and sensors, and to develop control algorithms that optimize performance and safety. In scientific field, it can be used to simulate complex physical systems such as fluid dynamics, structural mechanics, and quantum mechanics, and to develop numerical methods that ensure accuracy and stability. Now, what will be the future of linear algebra? We will look into the requirements and the challenges or the opportunities that we will face in the near future of linear algebra. Recent advances in deep learning, quantum computing, and network science are opening up new areas for the application of linear algebra concepts and techniques. The challenges: as the scale and complexity of modern data sets and systems continue to grow, there is a need for new algorithms, software tools, and hardware architecture that can exploit the power of linear algebra. To conclude this topic, the linear transformations and vector space can unlock the potential for innovation and discovery in computer science and engineering and create a bright future for everyone. Thank you. Thank you for watching.